A very good afternoon to our honest guests, respected superiors, and esteemed colleagues. As we gather today in this significant moment, the importance of our occasion becomes ever more evident. I am Veena, your host for the day. Welcome you all to the Valedictory of WSW 2024. From 4th to 10th of October every year, we unite under the banner of World Space Week, joining global efforts with this year's theme, Space and Climate Change. Our aim is to advance space technology in society through education, engagement, and dialogue. This year, URSC has embarked on an ambitious outreach program, lighting a passion for space science among young minds. Now to start with, I kindly request everyone to raise for the national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जनगण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
It's my honor to invite Sri Venkata Govind Rao, Chairman of Apex Committee of World Space Week 2024, to join our esteemed chief guest, Dr. R.R. Navalgund, and Director URSC on the dais. In keeping with our tradition to seek divine blessings for the success of our event, I would like to invite Sri Hari Krishna to lead us in invoking the blessings of the Almighty.
श्रीविनायकं नमाम्यहम् श्रीविनायकं नमाम्यहम् श्रीविनायकं नमाम्यहम् दयानिधिं शुभवरद श्रीविनायकं नमाम्यहम् दयानिधिं शुभवरद श्रीविनायकं नमाम्यहम् नमाम्यहम् वरगजवदनम् अनन्वयचरितं वरगजवदनम् अनन्वयचरितं करुणालसलसितोल्पलनयनं वरगजवदनम् अनन्वयचरितं करुणालसलसितोल्पलनयनं कलिमलरहितं सुरगणमुदितं कलिमलरहितं सुरगणमुदितं लासनानाजिपूजित पादं श्रीविनायकं नायकं नमाम्यहं रे-ग-प-नि सा-नि-ग-प-नि श्रीविनायक सा-सा-नि-नि-नि-प-पा-प-नि-ग-ग-प-प-नि-सा स-रि-ग-प-नि श्रीविनायकं नमाम्यहं नमाम्यहम् आना.
Thank you, Hari Krishna, for the melodious invocation. Leadership is the capacity to translate vision into reality. And this is precisely done by our chairman, World Space Week 2024 Apex Committee. His leadership was a driving force for the successful completion of outreach activities and other parts of Karnataka and neighboring states. This program is attributed to the steadfast guidance of our esteemed Apex Committee Chairman, Sri Venkata Govindra. I now invite our chairman, World Space Week 2024 Apex Committee, to welcome the dignitaries and the gathering.
Very good afternoon to all of you. Director URSC, distinguished chief guests, URSC council members, my dear colleagues, students, accompanying teachers from schools. It is with great pride and privilege that I welcome you all to the valedictory function of World Space Week 2024 here at UR Rao Satellite Center. The global celebration has been taken place from October 4th to 10th of this month to mark humanity's endless curiosity and ambition to explore the final frontier, space. This year, World Space Week is particularly special as it aligns with a theme that resonates deeply with the challenges of our time, space and climate change. In recent years, space technology has played a crucial role in addressing the growing concern of climate change, providing invaluable data that helps to monitor Earth's atmosphere, oceans, forests, and ice caps. Today is the culmination of a week filled with exciting programs, competitions, exhibitions that showcased our nation's achievement in space science and technology. We had activities ranging from scientific talks, exhibitions, interactive sessions with our engineers and scientists at 9 venues covering Karnataka and its neighboring states, that is Maharashtra and Tamil Nadu, which was overwhelmingly received by student communities. This has inspired young minds, deepened public understanding of space's role in combating climate change, and demonstrates ISRO's commitment to both space exploration and Earth preservation. All India Radio program was arranged in FM 101.3. Our eminent scientists spoke on various space explorations and science achievements. Each day there was a quiz in All India Radio for the listeners, and prizes are being distributed. For all the activities of World Space Week celebration of URSC, our beloved director is instrumental in providing valuable guidance and roadmap for conducting celebration in a meaningful way. Today, he is presiding this World Space Week 2024 valedictory function on behalf of organizing committee as well as on my personal behalf. I welcome Director Sir Sri Shankaran for this function. I request Saubhagya to welcome him with a sapling. Today's chief guest, a well-known personality in ISRO community in the field of Earth observation, Systems, Science and Applications. He was the Center Director of two major ISRO centers, NRSC Hyderabad and SAC Ahmedabad. We are fortunate to have Dr. Ranganath R. Navalgund in this valedictory function. I take immense pleasure in welcoming Dr. Navalgund sir. I request Shri Prashant to welcome him with a sapling. AD projects, the Nigar Shaji madam, I request student to hand over a bouquet. Now I request Jyotika student to hand over a sapling to controller madam. Students from different parts of Karnataka have travelled all the way and reached here on time to be part of this valedictory function. Teachers have taken special interest and accompanied the students. On behalf of URSC and entire ISRO family, I extend a warm welcome to our special guests, school students and the teachers. They are our young space enthusiasts whose curiosity will shape the future of space science. Let us take this opportunity during World Space Week to reflect on our shared responsibilities, our accomplishments, and our vision for a future where space technology continues to serve not just the advancement of human knowledge, but the preservation of our beautiful planet. Once again, welcome to World Space Week 2024 valedictory function. Thank you.
Thank you, sir, for briefing us about the World Space Week celebrations and URSC's contributions towards this. I would now like to invite Sri Kanakamohan to present a sapling to Sri Venkat Govindrao as a token of appreciation. A video will be played now, which has covered all the outreach activities and various programs of WSW 2024.
I'm going to talk about this year's theme for World Space Week, because every year the United Nations announces a theme on which the celebration for that year has to happen. So this year's theme is space and climate change. Whether climate change is a serious problem or not, for that evidence is required. What is the evidence? Evidence is by observing the earth continuously and compare how things have been progressing or deteriorating or remaining stagnant. What is happening? So that is the connection between climate change and space. We have been doing what we do. We keep satellites above the earth, which will keep watching and monitoring and sensing our entire globe for temperature, humidity, rainfall, and many other parameters, which allows us to model the global climate. Because as I told, the climate is a global phenomena. Even though there can be local variation, anything anywhere affects somewhere else. So to do this, only you don't have any known cause and effect. It is only done by theories. To make these theories and models, you require a lot of data. So the satellites what we put up generate all this data with which the scientists are able to build a climate model and predict what happens, what is going to happen, and that is what is going to help us to prevent.
What is the agenda of my science? Sustainable future. If I can ensure clean air, water, and environment to our children, next generation, that means I have done my science. That's the thing. Then, if we have to do that, you have to maintain the ecosystem integrity. To maintain the ecosystem integrity, you need to do the planning. To do the planning, you need the data. You need to understand the patterns. That is where this remote sensing comes to the picture. Message is loud and clear. When Mother Earth is covered with a green saree of native species, she retains the water for 12 months so that you have the livelihood. When you convert that green saree of native species into monoculture plantation of synthetic saree, she gives you water only for 6 to 8 months. When you degrade the catchment with a forest cover less than 30%, she retains the water only during the monsoon. Now you know what you are supposed to do. Respect mother at home. Then you will also respect Mother Earth. That's what we want so that we'll have sustenance of resources on the earth. Thank you all.
ಗೊತ್ತಿದ್ರೆ ಬೇಗ ಬೇಗ ಸಂದೇಶವನ್ನ ಕಳಿಸಿ ವಾಟ್ಸ್ಆಪ್ ಮುಖಾಂತರ. ನಮ್ಮ ವಾಟ್ಸ್ಆಪ್ ಸಂಖ್ಯೆ 9480901013.
Thank you, audiovisual team, for the wonderful video. True leaders inspire a hope for success and instill self-belief in their people. Director URSC is a source of inspiration for the successful completion of outreach and various programs. He is a guiding force behind the public outreach effort. His unwavering support and leadership has enabled this event to take place on such a remarkable scale. It is my honor and privilege to invite our beloved Director of URSC, Shri M. Shankaran, to deliver the presidential address.
Thank you, Veena. Good afternoon. So, welcome to all the children and the teachers accompanying them to the valedictory ceremony of the World Space Week 2024 at the URSC Satellite Center. As already pointed out by Sri Venkata Govindarao, this year's theme for the World Space Week is about space and the climate change. I'm not going to talk about either space or climate change because you have a very eminent expert here in both climate as well as space, Dr. Navalgun. So when he is there, if I talk about those things, it will not be proper. So I will not talk about either climate change or space, but I will talk about something else. You people listen to Dr. Navalgun and understand about climate change. But I will talk about why high technology, why higher studies, knowledge, ability and capability are required for us. Whether climate change is really happening. I was telling you would have heard in the initial, my inauguration speak time, I spoke about whether climate change is happening or not. For that, we need to have data, information. Now, how will you get information about the entire globe, entire world, the earth? How will you know? Because as an individual, we are very small. As a city, maybe slightly bigger. As a state, maybe even more bigger. Even as a country, we are still small. When all people in the world put together also, still all of us put together is very small compared to the earth. Because earth is comparatively very big. Now, how do you know about earth? For that, you need certain knowledge, ability, technology, all these things are required. But why we should do this? Why we cannot live like how some 300, 500, 1,000 or 10,000 years ago, how people were living? Why we cannot live like that? Without knowing anything. Like if you see some 200 years ago, people were simply dying. Entire villages, everybody were dying. People were not knowing why people were dying. They were dying. People used to attribute that to ದೇವರ ಕೋಪ ಮಾಡಿಕೊಂಡ್ರು, ದೆಯ್ಯ ಬಂದು ಹೊಡಿತು, ಸೊ ಅದಕ್ಕೆ ರಕ್ತವಾಂತಿ ಮಾಡಿ ಸತ್ತೋದ, ಇಲ್ಲ ಚೀತೆ ಬಿದ್ದು ಬಂದು ಸತ್ತೋದ, ವಾಟ್ ಎವರ್ ಬಿ ದ ರೀಸನ್. Because when we don't know, we attribute to something which nobody can question. Whereas now, we know when a person is dying with vomiting blood, we know what is the reason, isn't it? There is a hemorrhage happening, either he is having a very, very high hypertension or somewhere hemorrhage is happening. So we know, like even as early as about 75 years ago, people used to die in thousands in an epidemic called plague. Plague, I don't think any of you would have heard about plague. What is a plague? Plague is a disease which is spread by dead rats. When rat dies, because of that, the infection that happens creates a disease called plague. But nobody knows, at that time, nobody knew why they were dying. It was, in fact, plague amma, when God was created, and it was attributed to plague amma. So, not knowing the reasons results in superstition or attributing certain reasons to the most inconvenient, whatever is there, you attribute on that. Or where you cannot touch, where you cannot question things, you attribute that to this one. So for us all, very convenient is God or devil. Both are, nobody has seen either God or devil. Nobody has any control over God or devil. So you can tell either it is God or devil has done this. This climate change also is happening like that only. You ask, there are very, very rich business people who tell there is nothing called climate change. These are all bogus. People are simply trying to blackmail industrialists like us who make job opportunities by opening factories, doing manufacturing, and these fellows, scientists come and environmentalists come and tell you are releasing this to the atmosphere or into the river, and there is nothing like climate change. There are one group of people who tell that, and all scientists, environmentalists, up in arms, telling no, if people are killing earth, we should go back to nature. Carbon shatara idru parvagilla, we can go back to nature. That is one group of people like that also is there. So what do we do about this? So now we are in the second quarter of the 21st century. We cannot simply take anything on face value, because our civilization humanity has acquired so many capabilities of understanding things. Now, we have to make up our mind only based on evidence and data. So, scientific data is the basis of us coming to any conclusion. We cannot, because somebody is telling, we cannot simply accept it, isn't it? That is the reason we are all having jobs. Otherwise, ISRO people, 50% of the people will not have any job, because this is our job, because we need to do this. We need to make instruments which can measure these parameters. We have to make satellites to put those instruments on those satellites and operate the satellites, and when the data comes, analyze and give the output. So 50% of the people in ISRO will be jobless if we don't go by data and reason. So why I am telling this is, it is sometimes inconvenient to question also. It is difficult to question. When you ask somebody a question, you should have the power to analyze the reasons and come with an answer. But reasoning, questioning, finding out answers, and sometimes if you ask questions, your father, mother also would tell, don't keep on questioning this. I'm telling you, you do it. ನಮ್ಮಮ್ಮ ಅಪ್ಪ ನಮ್ಗೆ ಹೇಳಿದರು, ನಾವು ಅವ್ರನ್ನೇನು ಕೇಳಿಲ್ಲ, ನೀವು ನಮ್ಮನ್ನೆಲ್ಲ ಇದು ಕೇಳಿಬಿಡಿ. ಹೇಳಿದ್ವಿ, ಮಾಡಿ. Like that people will tell. So to overcome that, to understand what is happening requires some amount of perseverance. That is what I wanted to convey to all of you today on this day of World Space Week 2024 valedictory, that whatever we do, whatever we believe, should be based on evidence and data. Today you don't have evidence and data does not mean that does not exist. Because some 50 years ago, for many of our diseases, there was no medicine. People were simply dying. No, there was no question. Smallpox comes mean entire family will die. Today, nobody knows who has got smallpox, because till the time you find a vaccine for smallpox was killing the entire family. If it comes to a family, so they will not even allow people to come enter the house. They will put one from the neem tree, one bunch of leaves they will take out and tie on outside the house. That they will tell for this one to prevent whatever is Marama, to please Marama we are doing, but it is actually to warn people, don't get inside. If you get into this house, you can also get infected with smallpox. So there it is like that. We need the ability to understand and question. When you are asking questions, don't get satisfied with the answer. Try to analyze the answer, whether it appeals to your common sense. Sometimes common sense may not be correct, but at that time you have to ask the question and get answers from the people who understand these things. This is the message I wanted to give it to all you children, that not just only about disease or about climate change, any subject, anything, any issue, it is a fundamental nature of human being to be curious and to ask questions and to find answers, to experiment and also to be adventurous. This is the nature of the human being. That is how the humankind has evolved itself. What is the reason for that? We don't need to worry about it, but that is how it is. So cultivate the habit of asking questions. Don't take anything on face value. If you ask questions, you may get answers. If you don't ask questions, you will get beliefs. What people will tell, you will start believing. Whereas if you ask questions, you will get answers. Sometimes immediately you may not get answers, but if you persist with the question, sometime answer will come. No time is too late for getting an answer. Anytime we get an answer is good enough for us. The answer will come to us at the right time. So that is the message. So as I promised you, I never spoke about space or about climate change. I only spoke to you about being rational, ask questions and analyze things. Human brain is such a wonderful tool we have. All of us have something inside the head which is so capable of doing so many things. This is my favorite point which I tell when I go to outside to speak, is that when you consider yourself in the universe, we are all insignificant, very, very small, not even a speck in the size of the universe. The universe is so big because, as we told already about Earth and man, human being is so small. Earth is so insignificant in the solar system. The solar system is insignificant in the Milky Way galaxy. The Milky Way galaxy is insignificant in the entire universe. We are so insignificant. But that insignificant human being's brain is so significant, he is able to understand this universe. He is able to challenge himself or herself to go to moon, Mars, or even people are thinking that one day we will be going to the nearby star, Alpha Centauri. It is possible. It is the power of the brain that makes all this possible. There is nothing which is not possible or not feasible if you are determined to do it, and if you want to do it so badly, you will do it. So all the very best to all of you for your all future endeavors, both at school, subsequently in colleges, and also in your life. Keep asking questions and the answers will come. Thank you very much.
Thank you, sir, for your inspiring words about civilization has acquired capabilities to investigate and collecting the data, and about the human beings of a nature of curiosity. It's my privilege to introduce Dr. R.R. Navalgund, former SAC Director, Ahmedabad, and NRSC Director, Hyderabad. We are honored to have such a distinguished personality among us today as a chief guest. His insights will undoubtedly benefit our audience, especially the students community. I now call upon Shri Prashant to introduce our chief guest.
A very good afternoon to all. Indeed, it's a privilege, and I feel honored in introducing today's chief guest, a very well-known personality, particularly in ISRO community, our former Vikram Sarabhai Distinguished Professor, Visiting Professor IIT Bombay, former Director Space Applications Center, and former Director National Remote Sensing Center, Hyderabad, our Dr. Rangnath R. Navalgund, sir. Sir Rangnath Navalgund, after obtaining his doctorate degree in physics from the Tata Institute of Fundamental Research, Mumbai, he joined Space Applications Center, Ahmedabad, in the year 1977 of ISRO, and he has served in different capacities for the last 40 years. His major contributions, scientific contributions, are in the broadly in the areas of Earth observation systems, science, and its applications. He played an important role in establishment of several remote sensing application centers in different states of the country, and establishment of National Natural Resource Management System, we call it as NNRMS. As the director of National Remote Sensing Center and also the director of Space Application Center, the two major centers of ISRO, he provided scientific leadership and supervision for the development of electro-optical and microwave sensors, communication and navigation satellite systems and payloads. He was instrumental in establishment of Decision Support Center for disaster monitoring at NRSC. He represented ISRO from India at many multilateral international forums, such as UN Committee on Peaceful Uses of Outer Space, a Group on Earth Observation, Committee on Earth Observation Systems, and he also interfaced with several space agencies of major spacefaring nations, including US, France, China, and many others in the leadership role. He served as a visiting professor in IIT Mumbai during the period of 2015 to 17. He was the president of International Society for Photogrammetry and Remote Sensing Technical Commission, Chapter 7, during 2000 to 2004. He is an academician of the International Academy of Astronautics, fellow of Indian Academy of Sciences, and honorary fellow of the Indian Society of Remote Sensing. He is a recipient of many prestigious awards. Among them are M.M. Chugani Memorial Award of the Indian Physics Association in 2020, Aryabhatta Award of the Astronautical Society of India for 2012, Outstanding Achievement Award from ISRO, Bhaskara Award of the Indian Society of Remote Sensing, Maharana Uday Singh Award for the Environment for the year 2009, instituted by the Maharana of Mewar Foundation, Udaipur, Vasvik Award, and the Technical Excellence Award of the Tata Institute of Fundamental Research, Mumbai, beside many others. Sir, we are eager to welcome you for this function. Thank you, sir.
Thank you, Mr. Prakash, for that kind introduction. I sometimes feel embarrassed to hear among the people whom I know, Mr. Shankar, director of the UR Satellite Center, UR Rao Satellite Center, Mr. Venkata Rao, controller of the URSC, Nigar Shaji, Mr. Nadgowda, who is a very close friend of mine since many years, and many of my senior colleagues whom I know, all young children or young school children who I guess are in the high standards of 8th, 9th, 10th, right? And their teachers. I'm extremely happy to be here on this podium and to talk to you about space and climate change. I'm extremely happy to note, and I would like to compliment the Professor U.R. Rao Satellite Center on taking the initiative of outreach, trying to meet a large number of school children in different parts of this state as well as the neighboring states to inculcate a mind of inquiry, as the director put it, and also to learn about what space can do. I'm very happy on this initiative taken by URSC. I would also like to tell you that when I just entered this center today morning after a few years, I found whether there was some marriage going on here. Because I saw a lot of ladies with all silk saris and so on and very celebratory mood. Then somebody told me, this is Ayush Puja, and we are almost having a holiday. So I thought the director is so considerate and lenient towards allowing people to celebrate everything and be relaxed. So that's a good sign of a leadership. So I would like to take this opportunity to greet each one of you and convey my greetings of the ensuing Dasara. So to all of you. There are 5 points which I would like to mention to you. One is, what is climate change? Second is, what is the climate variability? What is weather? This is one part of the question that we would like to answer. Second, what are the factors which result or which are responsible for the change in the climate? What are those things? Third, what is the impact of climate change on our life, on the earth? How does it change? What are the things which change? Fourth, what are the observables which are because of the climate change, which related to land, ocean, and atmosphere, which we, working in ISRO, can make measurements and ensure that what we are observing are sensitive enough to support that climate change does happen or is happening. That is the fourth point which I would like to talk. And the fifth point that I would like to say is we as individuals, we as countries, what we can do to mitigate the effects of climate change. So all these 5 are important. So let me start from what is climate change. This refers to basically significant change in the various parameters that we refer to as weather, temperature, rainfall, or sea surface temperature, sea surface level, so many factors, snow and glacier, ice, etc. If there is a significant change, trends of change, over a minimum period of 30 years at least, then only, which is also verified, then only we say that there is a climate change. If not, it is only a climate variability. Last year, it rained heavily in Bangalore. This year also it rained heavily, but 2 years back or 3 years back, it did not rain very heavily. Such things are only variabilities, right? I'm only taking care of Bangalore, but it is true for all over the world. So, how do you differentiate the changes that happen on a yearly basis with respect to what changes happen over a minimum period of 30 years? That is what defines the climate change. Now, for that, immediately, those of you who are sitting here in ISRO Satellite Center should know that if I have to make measurements and prove, I have to see that the increase or decrease in any of the observables by any degree over a 30-year period is consistently high or low. That is very important. Just by observing something, you say, no, that will not do. Okay, so this is what is meant by climate change and variability. But along with that, many of you have heard the term global warming. Is global warming climate change? Global warming is only one aspect of the climate change. Global warming, what does it refer to? It refers to systematic increase in the average temperature of the Earth over a period of time. So if you take about our last 100 years, average temperature of the Earth has increased by 4 degrees or so. But in the recent years, those changes are now reaching a point of what is called as a tipping point. That is a point at which it might become irreversible. So that is called the tipping point. So this is global warming, okay? There's climate change, climate variability, weather, and we have seen what is global warming. Now, what causes the climate change? Now, there are a few factors which are important. First thing is, all of you have heard of greenhouse gases, right? All of you heard of greenhouse gases. What are these greenhouse gases? They are carbon dioxide, nitrous oxide, okay? Then methane, then SF6, they call, that is basically sulfur fluoride, this one. And there is also another element which is called black carbon. Now, these greenhouse gases are increasingly found in the upper atmosphere. Why is it happening? From the 18th century or so, when we had the Industrial Revolution in the West, people started using more and more fossil fuels, coal and also the crude, both of them. Once you started using this coal and the crude, etc., the amount of carbon dioxide started increasing. So obviously, what does happen to the carbon dioxide? That goes up to the atmosphere. Now, this carbon dioxide has a property to absorb long wavelength radiation. Now, what is long wavelength radiation? All of you know ultraviolet, blue, green, red, infrared, and beyond, right? This infrared and beyond, these are long wavelengths. These are absorbed by the gases like carbon dioxide. And what do? They re-emit that to the earth, thereby increasing the temperature of the earth. Otherwise, if any radiation which is reflected from the earth's surface, if it goes into space, sky, temperature will not increase. It is only because these long wavelengths which are absorbed by these gases, which are re-radiated to the earth, results in the increase of the temperature. Okay? That is increase in the global temperature. Now, what about methane? Industrial revolution, industrial productions, etc., brought fossil fuels and their burning and increased the carbon dioxide. What is the second most important thing? That is methane. You know, methane is found in the paddy fields, which are waterlogged. In the waterlogged paddy fields, this carbon which is there in the soils, actually anaerobic means without oxygen. It undergoes some reactions, chemical reactions, and forms CH4. This is all for school children, right? CH4 you have heard of, that is methane. And that is emitted. And this CH4 is more powerful, 6 to 8 times more powerful than the carbon dioxide in absorbing long wavelength radiation and re-radiating to the earth, thereby increasing the Earth's temperature, overall temperature. So this is the methane problem. That is why Westerners, Western countries, they blame those who are growing a lot of paddy. Who are the people who are growing a lot of paddy? India, Thailand, Indonesia, China, or even some of these countries grow more of paddy under waterlogged conditions. You know, waterlogged conditions. Even in India, if I make a measurements from space about methane concentration, I find methane concentration in the Kaveri Delta. In fact, in Tamil Nadu, they grow 3 times the paddy, right? Then in the Krishna Delta, Godavari Delta, Mahanadi Delta, and then Sundarbans, you will find concentration of methane compared to other regions of the country. So this paddy cultivation in the waterlogged conditions is another important factor which results in the emission of methane, which in turn results in the global temperatures increasing. Then there is one third one, that is livestock, that is cattle. Cattle, pigs, etc., in their stomach, they create a lot of methane. And that methane they emit, obviously they give out, and you find that that also is a very great source of this greenhouse gas. And you will find with that same map which I was telling you, that methane, if I plot over India, that is mostly seen over Rajasthan. Rajasthan has this large stock of cattle, etc. And mostly you find that methane coming from there. So these are two to three factors. One is, I told you, fossil fuels. Second is methane. Third one is when you forest, when you deforestation you do, obviously forest is reduced. That means that even whatever carbon dioxide they would have absorbed for their photosynthesis. All of you know photosynthesis, right? So that results in the decrease. If they don't, then the carbon dioxide doesn't decrease. So deforestation is another important factor. Now, this is called change in albedo. That means if the overall reflected radiation from the Earth is increasing and it is not going into sky or space, then it results in increase in temperature. Now, another factor which also people consider, That is the sun coming nearer to the earth? Earth is going nearer to the sun, so then the insolation, the amount of solar radiation coming is more. So that's why the temperature is going. No, that is not happening. That is not happened. In last many years, millions of years, insolation from the sun is more or less remaining constant. But solar flares, if they increase, then that also will increase the insolation on the Earth's surface and may add to this problem. But so far that is not seen. These are the only factors which are 3-4 points which I said are the factors which are responsible for the growing temperatures. And growing temperatures leads to, now, how does it affect? If the temperatures are increased, first thing what happens is the snow melts. In the higher reaches of Himalayas, Alps, Arctic, Antarctic, or any of these things, snow melts, and also glaciers melt, right? Now, if they melt, what happens? They go to the sea. So sea level rises. It is not just that the sea level rises, but also because of the increase in temperature, there is a thermal expansion of water. That is also results in sea level rise. So because of these two factors, sea level rise, when the sea level rise, all the coastal regions get inundated. And that is seen through tidal gauges, etc., in many countries. Tomorrow I mean a few tens or 20 years or hundreds of years, you might find no Sundarbans. Some islands might have vanished, etc. That is one impact of this particular thing. The second thing is, because the temperatures are higher, evaporation is larger from the sea water. If the evaporation is larger, that means the winds carry more water vapor. Second thing is, again, I'm asking all the students to remember that each gram of water, when it becomes water vapor or steam, it carries with it 540 calories per gram, isn't it? Latent heat. So the energy is more in the clouds. If the energy is more, cyclones are going to become very intense. Wind velocities are going to become intense. So that is why you find hurricanes and cyclones are becoming stronger. Whether the number is increasing, we don't know. But they are becoming stronger, that is known now. And they bring more moisture. So not only they cause damage to the coastal regions and others, but also bring moisture. Larger moisture means more rainfall. But more rainfall not necessarily uniformly over all the regions, but at places, depending upon the other conditions being favorable, very heavy rainfalls, etc. This is the second impact of this one because of the energy, because you have higher temperatures. Sea level rise, inundation, plus high amount of evaporation leading to higher moisture, rainfall, uncertainty in the places. Third important thing is higher temperatures affect crop yield. You know, for example, in Punjab and Haryana, or I'm talking about India, when the wheat plant has these small seeds, and that the small seeds have some milk in those things. Milk means not necessarily milk, but milk. And this, when it matures, it becomes a grain. Now, if the temperatures are higher, it matures faster. If the temperatures are cooler, these grains, that the milk becoming like a grain, is a slow process. Weight of each each grain changes by a few milligrams in case the temperatures are higher, decreases. So this has been seen even during the normal years. If the temperatures in Punjab, Haryana, etc., Madhya Pradesh are higher during February, then the grain yields become less. Okay, total yield becomes less. Not only in India, but all, whether it is Ukraine or Soviet Union or any of those things. Then what will happen is our wheat production will become less, our paddy production will become less. You will have a problem of feeding maybe 1.5 billion people, or in the world it is 7.2 billion people. So there is an effect on agriculture of increase in the temperatures. Initially, paddy yield might increase, but as after some time, it starts decreasing. This is one. The other impact that happens with respect to acidification of the oceans. See, after all, if there is additional carbon dioxide in the atmosphere, that gets dissolved into seawater. As long as it is in the initial stages, amount of photosynthesis increases. If more carbon dioxide means more absorption by the chlorophyll A pigment, so plants, etc., they can become more productive. But after some time, it becomes acid. CO2 plus H2O, H2CO3, right? Carbonic acid. So seawater becomes acidic. And if it becomes acidic, marine life will not survive. Fish will not survive. So this is the other impact which happens because of this. Then there will be heat waves, droughts, etc., becoming more frequent. Then there is another interesting thing. See, most of the plants, trees, forests grow at a certain latitude, altitude. Now, when the temperatures start increasing, they go to higher reaches. So what you see today at, let us say, near Dehradun, Mussoorie, you will not see them. They will be at the higher reaches of maybe Kedarnath, Badrinath, etc. They will go up because the temperatures up are slightly higher than the ones which were there earlier. So this tree line change, which has been seen from satellites, is also a result of this kind of an increase in the temperatures. So there are many such impacts which are extremely, detrimental to the overall health of the human population as well as marine life is likely to happen with the climate change. Now, why are we using satellites? Why can't we go and measure? Obviously, this is a very simple question to answer as far as you are concerned. In situ measurements, that means at different places, how many can you make? It is the satellites which can make over synoptic coverages, right? It can cover large areas, it can cover frequently, and it can make measurements at all wavelengths, right? From blue, green, red, infrared, thermal infrared, microwaves, etc. And you get different properties of the Earth, ocean, land, and atmosphere. So space people have been doing this kind of measurements over the last many years of these measurements. Most important is sea surface. How do you get the sea surface from satellites? In satellites, you put an altimeter. Altimeter sends a pulse. It goes and hits the sea surface. It comes back. So that time you measure, and time obviously will tell you the range, and you get the sea level. Of course, it is not as simple as I said. There are a lot of corrections and so on and so forth. But this is one thing which people have been measuring with the sea level. Now, there is a lot of influx of fresh water because the snow and glaciers are melting, Arctic and Antarctic sea ice, etc. That is coming to the oceans. That means the salinity is changing, right? Sea salinity changes. you can measure sea salinity from satellites using microwave radiometers, right? SMAP, SMOS, etc. are there. So they are measuring this one. Sea level, sea surface temperatures you can measure, sea surface salinity you can measure. There are precipitations you can measure. There are radars which can measure temperatures. Then over land you can measure total amount of forests, total amount of agriculture areas, total amount of arid lands, total amount of snow cover, how are the glaciers, and you know that we have done a detailed study and we have found in the last 1985 to 2020, around 2,000 glaciers. In all, there are 32,000 glaciers in the Himalayan range, Indus, Ganga, Ganges, and Brahmaputra, 3 basins. Out of that, we have measured 2,000 glaciers very closely for 30 years. Out of 2,000 glaciers, a large fraction of them have retreated. A small amount of them have been steady, no retreat, no accumulation. Some of them have accumulated. Some of them which have accumulated are in the Karakoram region, which are not facing the southern hemisphere. So such measurements have been done, and the satellites can make measurements of every year how much glacier is retreating to go into the higher latitude. For example, Gangotri over the years has more than 100 meters, it has gone up. This you can do. What is the snow cover? Is it changing? That you can measure. So soil moisture you can measure. That is also another important variable. All these things, atmosphere, water vapor, atmospheric gases. For example, you want to measure carbon dioxide. So you take a sensor which actually measures the carbon dioxide columnar. That means right from that up to the Earth's surface. Is it increasing? And that has been measured by many satellites. The most recent GOSAT, it is more than 400 ppm, which was about 250 ppm some 100 years earlier, 200 years earlier. So all these measurements are possible to be done by the satellites. Now, most important thing is, as I mentioned, is the calibration of these sensors, because you have a satellite, let us say, which is only 5 years or 10 years is there in the space. So within 10 years, what you have measured may not show a significant change, but you will put another satellite. But that satellite sensor, with respect to the earlier sensor of the satellite, both should have intercalibrations. Or if you have satellites from somebody else, you should have intercalibration of those things. So you must have consistent, calibrated data in order to make meaningful observations that something had changed. This is very important. So people have measured it, and they find that 3 millimeters approximately of change in the sea level, totally about 1.2 degrees centigrade over a period of time, and chlorophyll, that is the amount of phytoplanktons in the sea, that has shown a change, that has shown an increase. See, for example, we have ocean color monitors since 1999, and I had asked somebody to make measurements. Of course, I don't believe them, because 99 ocean color monitor is different from 2009 ocean color monitor compared to 2022 ocean color monitor. So you will have to make sure that all these 3 sensors are calibrated with respect to each other and vicarious with respect to some measurements in the sea also, in situ measurements. So all this can be done using satellites. So all these, most of the measurements which we do today in order to support climate change in terms of these what we call as essential climate variables, okay? These are called ECVs, and these are about 50. Out of that, 27, 28 are amenable to space, and they are being measured. and India is also part of this measurement. And India, some of the Indian satellites, for example, we had the Saral, which measured the sea level, sea surface heights. We had many INSAT measurements which can measure the water vapor. We have the scatometer which can measure the wind vectors. So some of these things do give you some of these essential climate variables. But so far we don't have any of those sensors which can measure greenhouse gases like methane or carbon dioxide or any of those things, for which we are dependent on satellites which are international in character. But those data is available. Although we made one methane sensor which we flew on Mars, right? But Mars is a different ball game, because in Mars you are trying to measure parts per billion, not parts per million, but parts per billion. It is much more sensitive instrument which is required, but we are capable of measuring or making these sensors for greenhouse gases, and this will be useful worldwide, and they can also be used intercalibrations. Now I would like to come to the last topic, that is mitigation. How do we reduce the effect of the climate change individually or in terms of countries? One of the important things which has been mentioned is that we must reduce extraction and use of fossil fuels. That means we must reduce coal extraction and use less in thermal power plants, so you don't produce too much carbon dioxide. But a developing country like India, which requires a lot of power, we are unable to do so, right? This is one of the bone of contention between the Western countries and India. So there are technologies which say that you use coal, but you make sure that you get less of carbon dioxide. So India is saying, you please give us the technologies. This is one. Second is reduce paddy cultivation. Eat less rice. All young kids here. Eat less rice. Don't depend upon so much of rice. Eat millets, jawar, bajra, etc. Because they don't require so much of water. They are good for health. If you are eating rice, that means you are basically, 1 kilogram of rice requires 4,000 kilograms of water. You are not only using a lot of water, but also producing a lot of methane, which is a greenhouse gas. So eat less rice. Reduce forest fires, degradation, and as well as do a large amount of afforestation, so that because the plants absorb carbon dioxide, right, for their own photosynthesis, etc. So you do that. Don't go to the school by car. Use pooled car. If, in fact, better, go by bus. Still better, go by bicycle, right? So that you reduce on your own as an individual, right? Countries have many more things to do, but even as an individual, you can help in the mitigation of this climate change. Then there is one more new technology which has not been completely proven, that is called biochar production. What does it mean? It means you take a large amount of carbon dioxide, whether it is from that upper atmosphere or whatever it is, or waste, etc. You burn it in a confined atmosphere without oxygen, in a confined space without oxygen at 450 to 700 degrees centigrade, then you get pure carbon, no carbon dioxide, and you store it. So you are reducing carbon dioxide, this biochar. After all, how is the coal formed? Coal is formed inside the earth over a long period of time because of pressure. There is no oxygen there. That is how your coal is formed. That is what you are using. So this is a reverse process, biochar production. So maybe one of you can think, young man can think of having what shall I say, sucking all the carbon dioxide from the upper atmosphere, bringing them to a laboratory, a factory, and burn it between 450 to 700 degrees centigrade without giving oxygen. Okay? Then it becomes pure carbon, carbon dioxide is reduced, there will be less global temperatures, and you will have no climate change, right? So this is another way of doing, mitigating climate change. So there are many, and we have done our own contributions with space, but we are yet to do much more than what we have been able to do so far. But there is another thing, that is you can promote using other sources of energy, like nuclear energy, wind energy, tidal energy, solar energy. All these 5 do not produce carbon dioxide, right? So why do you use coal? So use these things. But of course, there is a problem. There is economics involved in it, because you need to, any of those things, if you say that you will again use some fuel somewhere, etc. But still, these are all so-called non-renewable, renewable resources. So you perhaps should get into more of this nuclear energy, solar energy, wind energy, and tidal energy. I think that is another thing in which you can mitigate. So I think I will stop at this stage. I have just explained to you climate change, climate variability, global warming, what are the factors which are leading to climate change, what is its impact, what is it that I can make measurements with space, and how is it that I can mitigate the effects of climate change. Thank you very much, and I am open to your questions. Okay?
Good afternoon, sir.
You are not you are a teacher.
Yes, sir, I am a teacher.
Okay, all
I am
right.
Ashok Poojar. I am a PGT Physics, Navodaya Vidyalaya, Dodbellapur, sir.
Huh?
Navodaya School, sir, Dodbellapur.
Dodbellapur, okay.
Yes, sir. Sir, I have one doubt, sir. Sir, I'll appreciate the space technology. The development that has been taken place in space technology is very much appreciated. It's all because of the space technology. Our life has become more comfortable, sir. Now, satellites are being used to predict whatever the earthquakes which are going to happen, the, this cyclone things which are happening, all these things that we are predicting, sir. But why satellites have been failed to predict the landslide which has happened in Wayanad, sir, Kerala?
Acha. Yeah. Let me give you an answer, slightly long answer. There are disasters are drought, floods, earthquakes, landslides, volcanoes, storm surges, and so on. Okay. Out of these, floods, one is able to early warning or predict because of a lot of models and a number of observations on rainfall and how they are moving at a given time from space and other data. Cyclones, right from the day they are born in the oceans, and the winds that you measure, the total heat content, you are able to see their tracks and measure the wind velocities and see where they are going to fall on the land, that is landfall point, and what is the likely velocity. Drought, because of the rainfall deficiency, etc., you are able to say. Landslides, earthquakes, and volcanoes. These 3 are the more difficult naughty boys. Now, among them, volcanoes, by measuring the temperature on the top of the volcano, known volcanoes, when there is an increase in the temperatures, one knows that it might erupt in a few days. This kind of a thing also has been done using satellites. Now, as far as landslides are concerned, they are caused by two factors. One, if the earthquake has occurred somewhere, then landslides take place. Or there is a heavy rainfall, and the heavy rainfall goes through the land at some places, and the land, between the two pieces of land, the friction is reduced, it slides. This particular portion of the land slides. This has been, what should I say, the potential sites for the landslides to occur have been identified using satellite as well as in situ measurements. But if man deliberately makes this land, soil, weak by cutting trees, by cutting this one to make habitations, etc., the landslide is likely to occur more. And this is what happens in many of the regions, is not because of the lack of knowledge, but because of the man's greediness. As far as the earthquakes are concerned, earthquakes have not been predicted so far using scientific methods anywhere. Earthquakes occur when you know plate tectonics, plates move one over the other. One is going over the other, it is pushing, so there is the energy created, and that energy becomes more than something at a particular time. At that time, ruptures, earthquakes happen. So, some of these signatures which are leading to an earthquake are that the surface is deforming near the place where it is happening. Certain gases are also emanating. Sometimes there is a change in the temperature. These are all measured, and almost all earthquakes which have occurred, there is a correlation between these surface deformation, temperature anomalies, and the concentration of gases and the occurrence of the earthquake. But all this is post-mortem. If you go reverse, can you say that this is increasing surface deformation? So earthquake will occur at a point. That is not still done. Okay?
Sir?
Yes.
Sir, can we use helium balloons instead of the rockets?
Yes, you can use earlier, where you are here. Balloons can be used, but balloons were in fact earlier used. But the balloons can go maximum up to 40 kilometers.
So means after reaching out of the Earth orbit, it can be known.
No. You see, balloons work on what principles? Balloons have something, the pressure, basically pressure gradients. So balloons will burst if you go much higher. Inside there is no outside pressure becomes higher, so it will burst. So balloons are known to be used for many of the measurements up to 40 kilometers or so. Of course, recently Chinese are probably sending them at a much higher altitude also. But and second thing is, balloons cannot carry as much weight of payloads as the satellites can carry. And satellites go up to 700, 800, 900 kilometers, and they can carry a lot of weight. They can stay there for 5 years to 10 years, whereas balloons will not last for many days, for weeks. So balloons are useful, but not as much as satellites.
Thank you, sir, for your information.
Yeah. This is the global warming. Warming up is taking place now.
Good afternoon, sir.
Yeah.
Do we have any space technology to find out prevalence or spread of diseases like COVID-19?
In fact, I did not mention, one of the things that can happen with climate change is these epidemics. People say I mean, this is yet to be proven completely. Humidity increases, and that humidity increase in higher temperatures, with higher temperature, leads to all these viruses and many of those diseases, etc. So people do expect that some of the incidences of epidemics is likely to increase. But there is no clear-cut answer as of now, but it's possible.
Sir, while you were talking about the space sciences, you mentioned about the solar flares, sir. And you also mentioned that we have no worries to be worried about the solar flares. Sir, can you please explain how do they pose a serious threat in our near future, or we don't have to worry about it in our near future, or what is this phenomenon of solar flares, sir?
Yeah. Now, every 11 years there is something called a solar cycle in which there are solar spots or flares. That means some additional energy comes out of the sun, and that goes all around the complete space, right? And when it happens, it also comes to the earth, right? But it is for a short duration of time, right? And during that time, fortunately, because earth has a magnetic moment, earth has magnetic field, right? So it has a magnetic moment. So those are all ionic, there will be ions in that. Ions means either positively charged or negatively charged particles, right? So this magnetic field dispels, that means it doesn't allow that to affect the earth. At the same time, at the higher latitudes, that is at the North Pole and the South Pole, magnetic field is zero. Earth's magnetic field is zero. That is why there, when the solar radiation, whether it is from solar flares or the normal radiation, solar radiation, that interacts with the molecules, the atmospheric molecules, and that is why you get those auroras, right? That lights, what they call as night lights, etc. And if you have noticed, during the recent 10, 15 days, or even in the last 1 month or so, these auroras have increased because there was a solar activity. And that is coming to, in fact, lower latitudes than earlier. So this is something which is because this phenomenon, magnetic field is not there, or it is very weak in case of Mars. So there that will affect. Okay. Now, I must also tell you, Venus is already a greenhouse planet already. Okay. So this solar flares and sun, but distance between the sun and the earth and its orbit, etc., have not changed over the years so much. See, the earth and the sun is about 4.2 billion years old, right? So it will take another 3.7 billion years for it to completely sun to become a red giant. When it becomes a red giant, Earth will be encapsulated by the sun itself. That means Earth will be part of the sun. But that takes so many billions of years. So in your lifetime and in my lifetime, of course in my lifetime it is much earlier, nothing of that kind is going to happen. Okay?
Thank you, sir.
You got it?
Yes, sir. Thank you.
Sir, you mentioned that.
Yeah.
You mentioned that global warming is due to the increase in temperature.
Huh?
Global warming is
Yeah.
due to the increase in the temperature. How do we measure the percentage of carbon dioxide in the atmosphere?
How do you measure the?
Percentage of carbon dioxide in the atmosphere.
You see, each gas, carbon dioxide or oxygen or nitrogen dioxide, each of them have what we call as absorption lines. They absorb light at different wavelengths. Okay? So, by measuring the radiation at those wavelengths, you find out that this is belonging to carbon dioxide. Okay? You identify that. That is how the sensors are designed to measure radiation coming at particular wavelengths, which are absorption lines of these gases, like carbon dioxide. For example, carbon dioxide, roughly between 13 to 15 micrometers, that is absorption by the carbon dioxide. In fact, earlier, our satellites were using what are called as horizon sensors in order to find the nadir of the Earth by looking at the horizon, because you look at the carbon dioxide absorptions at two places and finding out the nadir. So ultimately, it is the spectrometry, spectrometer. Spectrometer means you measure the wavelength at which a particular gas absorbs. Okay? You design a sensor for that wavelength or another wavelength, two wavelengths, so that you are more consistent, and that will provide you which gas it is. Similarly for CH4 also, methane also. Okay? See, you must have learned how did the scientists find that sun consists of hydrogen. You are read it is there in the, your 9th class or 8th class science book. Hydrogen lines were seen, right, by people on the earth, and that is how they found out that hydrogen is there in the sun. And then people said hydrogen fusion takes place and energy is released, etc. Anyway, even if you have not done, you go back and read it.
Good afternoon, sir.
Yeah?
Nowadays, we are hearing that ozone layer getting damaged. So what is the reason and cause in damage in ozone layer?
Yeah. See, ozone, first of all, ozone layer is not getting damaged these years. Some 10-15 years back, ozone layer had a hole, particularly over Antarctic, but all that has stopped. Now, there are something called fluorinated gases, which were earlier used in large air conditioners and other places. And these gases, when they go, they interact with ozone and dissociate ozone into O2 plus O. Okay? That has been stopped by many of the countries. So now ozone depletion or ozone hole is not taking place. Okay?
Yes, sir. Thank you.
Good afternoon, sir.
Yes.
Sir, when we send a rocket to a space, there will be cause of pollution when it's going.
Yes.
No, sir. So technology is developed nowadays, no, sir. So they can find any eco-friendly rockets to launch for the space, sir.
Eco-friendly rockets?
Sir, as technology is developing nowadays, they can find it. No, sir.
Yeah, I agree. If you have only, I don't know because I'm not a rocket man. Maybe Director Isaac can explain. But to me, it looks that if you have only liquid hydrogen, liquid oxygen engines, that is cryogenic engines, there is no pollution. Whereas if you have solid rockets and earth storable liquid rockets, then yes, there is a pollution. See, he agrees with me, so it's fine. Even if you have semi-cryogenic, which uses kerosene, you will have carbon soot, etc. So that is a problem. So eco-friendly is liquid hydrogen, liquid oxygen.
Thank you, sir.
Okay.
A pleasant afternoon, sir. Myself, Sanya Rupawat of class 12th from Jawahar Navodaya Vidyalaya, Bangalore Rural. So my question to you is, we have a lesson in which it describes Antarctica as a place where we can able to see our Earth's past, present and future. So sir, can you please explain how we can able to predict the future of Earth by just observing the Antarctica? Thank you.
You know, recently I saw in somewhere, I don't remember where, Antarctica is greening. You know, Antarctica is greening. That means a lot of vegetation is growing on Antarctica now. Because of this, snow cover is decreasing, sea ice is melting away, and the soil is exposed, and temperatures are rising, so vegetation is growing. Okay? But whether Antarctica is a past, present, and future of Earth, I don't know. But definitely it is showing signs of what is likely to happen. Okay. Yes?
Good
Hi.
afternoon, sir. You mentioned that the Earth as well as Sun is 4.2 billion years.
Huh?
You mentioned that the formation of Earth and Sun took place 4.2 billion years ago.
Huh. No, total is 14 point some billion years ago, but the Earth formation with respect to the Sun was 4.2 billion years ago. Yes, then.
And there are many theories like Big Bang theories put forward to mention the formation of Earth or our solar system. But through the help of satellites, can we predict how old the Earth is or how our entire universe is formed by tracing the particles in the space?
Today's satellites?
Yes, sir.
Yeah, you know, you have to study cosmology as for your PhD, as far as the answer is concerned. But let me tell you, 14.2, I think, or 14.3, I don't know, billion years ago, from a singular point, there was an explosion. That is the Big Bang theory. And from that, you know, for after many years, many millions of years, etc., gases were there. They were going around with lot of energy. That is how the stars and the galaxies were formed. After that, the planets were formed. Okay? That is how the evolution has taken place. Now, there was a certain amount of radiation which was emanated during the Big Bang. Now, what it should be today, what is the background radiation should be there today, from which I can calculate back and say that it happened so many years back. Towards that, scientists from the Earth, they made measurements of microwaves. And that is called microwave background radiation, which is around 0.3 or something like that. So from that, this one, 0.3 degrees Kelvin or so, radiation corresponding to that has been detected. That is how these years have been calculated. Plus, of course, the redshift, which is there, that is the change in the wavelength that you see from in the light which is coming from distant stars, which is measured on the using some spectrometers or telescopes on the Earth or on the satellites. You can measure how fast or how far is the star or the galaxy. This is used. Yeah. Okay.
Thanks. We can end the question session. Thank you, sir, for the inspirational talk on climate change and their impacts and global warming and their effects on the earth and this marine life. On behalf of the organizing committee, I now request Director URSC to present the memento to Dr. R.R. Navalgund as a token of appreciation. Thank you, sir, for accepting our invitation and gracing us with your presence. I now call upon Shri Kanakamohan to deliver the vote of thanks.
Good afternoon, everyone present here. It's a great honor for me to extend the vote of thanks on this remarkable occasion as we conclude the World Space Week celebrations, not only here at the URO Satellite Center, but also across multiple venues in Karnataka, Tamil Nadu, and Maharashtra. Our journey towards the World Space Week event began with the formation of dedicated committees and numerous meetings requiring meticulous coordination. I am proud to say that through our collective efforts, we successfully executed this grand series of events. A significant milestone this year was our decision to extend the celebrations to neighboring states, a first-time initiative by URSC. This expansion not only allowed us to broaden our reach, but also make these celebrations truly pan-regional. On behalf of World Space Week 2024 Committee, I would like to extend my heartfelt thanks to our chief guest for today's valedictory function, Dr. R.R. Navalgund sir, for accepting our invitation and gracing the occasion. Despite his busy schedule, he joined us today and delivered a truly inspiring valedictory address, shedding light on climate change mitigation, the critical intersection between the space and climate change. Sir, your insightful closing remarks left the audience energized and motivated, providing a perfect conclusion and marking a fitting end to our celebrations. Following the visionary instructions of our director URSC, we expanded our outreach beyond Karnataka, celebrating World Space Week at 6 venues in Karnataka, 2 in Tamil Nadu, and 1 in Maharashtra. This bold initiative brought the spirit of space exploration to new regions, fostering enthusiasm and curiosity among thousands of students and members of public. Sir, your unwavering support and trust have been instrumental in empowering us to carry out of this mission with confidence. Thank you, sir. I would like to express my sincere gratitude to our controller, URSC, for the invaluable support and guidance provided throughout the World Space Week celebrations. Your leadership in ensuring smooth coordination across various departments, as well as your unwavering commitment to make this event a success, has been instrumental. Thank you once again for your support and dedication. I would also like to express my gratitude to the associate directors for their unwavering support in making the function a grand success. Your guidance and encouragement have been invaluable throughout this event. I would like to extend my heartfelt thanks to the 5 teams who traveled to various venues across Karnataka, Maharashtra, and Tamil Nadu. Your dedication and hard work ensured the smooth execution of World Space Week celebrations, inspiring students and public alike. Thanks to all the 5 teams. The venues covered are Hosur, Holagur, Chikmagalur, Hebri, Hospeta, Bellary, Ichikalgurinji, Chikkodi, and Coimbatore. I would like to express my deep appreciation to the chairman and alternate chairman of the Apex Committee for the straightforward guidance and encouragement throughout this journey. Without their leadership, this event would not have been achieved such a resounding success. In collaboration with Prasar Bharati and All India Radio, URSC hosted a daily space quiz from October 4th to 10th on Radio Rainbow Kannada FM 101.3, airing from 3 to 4 p.m. The quiz sparked excitement and curiosity among the listeners, with winners received prizes. Our partnership with All India Radio also brought expert talks on space science and the World Space Week 2024 theme, engaging a wide audience and deepening their understanding of space impact on daily life. This program greatly contributed to the success of our celebrations. A special thanks to the All India Radio team for their support. I would like to extend a heartfelt thanks to the following teams: drafting team, CIG, MDOG, admin, accounts, purchase, canteens, C&MG, transport, and CISF. Lastly, I would like to extend a special thanks to all the committee members and volunteers for putting hard work and seamless execution, ensuring that every event was conducted smoothly and successfully. As we conclude this year World Space Week celebrations, inspired by the endless possibilities of space explorations and united in our shared passion for discovery. Thank you all once again for making this event a grand success.
We conclude the valedictory function. Thank you, everyone.